All right, today, lesson 24A, more on the idea of functions. We're going to put lots of different things together today, in addition to adding a couple of more things, one of them going into a little bit more detail on independent and dependent variables, and so on. So, a little bit of review of what we've been talking about. So today we put the finishing touches on the top essential question there. We've dealt with functions with relation to equations and tables and graphs, and today we add verbal rules to that. And then we're also going to add functions to model relationships between quantities, which is the other piece of all of these problems for today. And so what we've talked about in this unit so far, and the reason why there's a lot of background knowledge at the very beginning today, is because our next quiz is tomorrow, and it will cover through what we do today. Now, I will only put one problem from what we do today on tomorrow's quiz, and the reason, and normally I don't do that, but the only reason I'm going to do that this time is because it's just really an extension on things that we've done lots of times, okay? So we've talked about how to determine whether a relation is a function based on a mapping or a table of values or a graph or a set of ordered pairs. We've also talked about how to find the function rule from a table or from a graph. So you can certainly expect those sorts of things to be on tomorrow's quiz. And then the relationship between different things that represent x values like input and different things that represent y values like output, or the other names that we've used like domain and range and independent and dependent variable, which once again we'll go into a little bit more detail today. All right, so I gave you in the first lesson really kind of an informal definition of a function. Today I give you the formal definition. And I know we've got some blank areas in our notes to fill in here. And so the formal definition of a function is this. Given two variables, x and y is a function of x if there is a rule that determines one unique y value for a given x value. Now the reality is it really means the same thing as the semi-informal one that I gave you before, but I wanted to make sure that I gave you the formal definition. Okay? All right, so we've talked about all of that. Now I brought this back up because one of the things that we're going to add today is making sure that we write a rule or a linear equation for the situation, if we can. Okay? All right, so let's go into number one. You go fishing and catch 3 fish each hour. You have a table that you're going to fill in all of the y values, but before you do that, look up here, please. I have a question for you, and that is this, because that's the new thing for today. We have verbal rules. So, and I want you to think about this. Does this verbal rule, do you think that it's going to represent a function? Let's think about that. And I would like you to have a conversation with your shoulder partner discussing the reason why or why not. Go ahead. All right, so mostly what I heard, and I was over on about two-thirds of the room, was yes, and some of you were talking about like 1 hour, 3 fish, 2 hours, 6 fish. Some of you were talking about, and some of you were using your arms to show what the graph of that would look like and so on. But it is a function, and we're going to go through all the reasons why here in just a second. So right now, go ahead and fill in the table and plot your data. I'll get back to you in about a minute and a half. All right, so let's go through number one. And the only instructions that I gave you were to fill in the table and plot your data. Many of you are so used to when you plot your data, you draw a line through that you automatically did that. Well, one of the new things today is we have two different types of relations in math, and we'll define what they are in just a second, but they are discrete relations and continuous relations. One of them means that we should technically draw a line through our data, And the other one means that we should. One no, one yes. And so we're going to come back to that in just a second. So some of you will have to maybe do some erasing or add some things to your graph. So clearly, the number of hours spent fishing, that is on your x-axis, but what you're going to find out in the homework tonight in 1 through 3 is you're going to have to state what the label should be on your x-axis or your horizontal axis and what the label should be on your y-axis or your vertical axis. So time spent fishing, since that's the independent variable, that's the x-axis, and number of fish caught will be our y-axis or our vertical axis. And we caught 3 fish each hour, so 3, 9, 2, 6, 1, 3, 2, 6, 0, 0, and 4, 12. Now on purpose, I have a 2, 6 and a 2, 6 in there because what I found the day that I put some problems in the homework where I asked you if a scenario was a function, I purposely put one problem where there was a repeated ordered pair there, and some of you had answered that one incorrectly and had to regenerate a similar problem. But when you graph your data, clearly this is a function. So if one of the 2, 6's was 2, 7, for example, then this wouldn't be, but the way that it is a function. Okay? So this is a function. The number of fish caught is a function of the number of hours spent fishing. Now, one other thing I want you to add to your notes would be the equation that represents this scenario, and that would be y equals 3x. For several reasons. One is all of the y values are the x values multiplied by 3, or you should be able to tell that from the verbal rule up there. But the other thing I want you to keep in mind, because this comes into play in the homework, is this. We don't always have to use variables x and y. Like this could be variable a, and this could be variable q. And if that's the situation, then that, of course, changes our equation. So you need to keep that in mind when you're doing those first 3 problems in the homework tonight. Also, this is an example of a proportional relationship because the graph appears to be linear, goes through the origin, the equation is of the right form. In addition to that, the independent variables are the number of hours spent fishing. Can you add that to your notes, please? And the dependent variables are the number of fish caught. And the reason is because the number of fish being caught depends on the number of hours that you fished. And that's how you always make that determination. One thing has to depend on another. And whatever that thing is, that is the dependent variable. All right. So next, the big question here is, should the points be connected? Well, let's define what those 2 relations are that I talked about just a second ago. So we'll come back to that graph in just a second. A discrete relation is one that has x values only at distinct points. And I know we've got some blank areas to fill in here. So an example of a discrete relation is the number of students in this class. We can only have whole number values for the number of students in the class. That's what x values at distinct points means. You can't have half of a student. So in a situation like that, you would not connect your dots together. And you may want to add something about that to your notes. Discrete relations, we don't connect the dots together. Whereas continuous relations, we do. Because continuous relations have values for all x values. And to me, a perfect example of that would be like the height of a rocket as it is shot into space. And the reason why that's continuous is because it could be at 1,000 feet. It could be at 1,000.5 feet. It could be at 1,001.4852 feet. So we have values in between other values. Okay? Discrete relations don't connect. Continuous relations, we do connect. And we're only focusing on the x value. So let's go back to the previous problem. Our x values or right here. So I realize in our table we only have whole numbers. But we're talking about number of hours spent fishing. So if you went fishing, could you fish at some value between 2 and 3 hours? Could you do that?
Yes.
Yeah. Like 2 hours and 5 minutes or 2.5 hours. So if you can, if it does make sense to do that, then it's okay to connect your dots together. If it didn't, then you wouldn't. So in this scenario, this is a continuous relation, so we should go ahead and draw our line through there. Now, in some of the problems in the notes, they're going to be discrete. In some of the problems in the homework, they're going to be discrete, and you're going to have to think about that. Okay? All right, so let's go to number 2. Similar type of problem, but this time your best friend goes fishing and the data is already filled in the table. Can you go ahead and plot the data? The two big questions right now for these first few problems would be this. Is the scenario a function? That's question number 1. And question number 2 is this a discrete relation or is this a continuous relation? In other words, should we connect the dots or not? So quickly have a conversation with your shoulder partner. Function, yes or no, discrete or continuous? Go ahead. All right, so if we plot our data, it looks like this. It should be very clear from both the table, because we have 3,1 and 3,8, or from the graph failing the vertical line test, that this is not a function because of those two pieces of data right there. All right? The number of hours fishing was basically the same scenario as the last one. We can fish for an hour and a half, and so therefore we should go ahead and connect our data together. And the reason is it's very simple. It's because we can fish that length of time right there, or that length of time right there. It's okay to do that. All right, I'd like everybody to try number 3 all the way through, please. So as you're doing number 3, notice that there is a question right below number 3. Go ahead and answer that question. And then, based upon what your ending result looks like for your graph, I can tell whether you mean discrete versus continuous. If you connect the dots all together, then you mean continuous. If you don't connect them together, you mean discrete. These are all questions, however, in these first 3 problems in the homework tonight that you're going to have to answer. And by the way, when you're doing your graphs, if you accidentally draw a line through and you weren't supposed to, points for that part will be taken off, obviously. All right, let's take a look at this. We plot our data, and from the table or from the graph, we can clearly see that this is a function. The equation that represents that scenario is y equals 2x. Go ahead and add that to your notes, because the number of gumballs was twice the number of nickels. And that's one of those things you're going to have to do in the first 3 problems in the homework. And then the next question, and this once again is a proportional relationship, is whether this is discrete or continuous. Discrete or continuous? Discrete. Discrete. And once again, all you have to look for, and obviously the number of nickels would be the independent variables, and the number of gumballs dependent. But all you have to do is look at the scenario for the x values as far as discrete or continuous. Does it make sense to have 1.7 nickels? And of course, it does not. So therefore, this is a discrete relation. We do not connect the dots together. All right, everybody try number 4. Same thing. Question number 1 was whether this is a function or not. Clearly, it is not. I mean, if you look at the table, you've got big problems there. However, even if you didn't see that, the graph should clear it up. Fails the vertical line test. We're still talking about number of nickels compared to number of gumballs, so clearly this is discrete just like the last one was. And then the equation, since we end up with a vertical situation here, ends up being x equals 1, and you may or may not get one like that in the homework, so just be aware of that. Okay, so here's what I want you to do. Listen carefully. With your shoulder partner, you're going to do number 5 and 6 and 7. Listen carefully, though, for number 5. The other two are self-explanatory. Number 5, if you can answer all the questions that I've been having you answer without filling in the table, you don't need to fill in the table for number 5. Number 6, though, I do want you to fill in the table. Okay? All right, with your shoulder partner, number 5 and 6 and 7. I'll get back to you in about 4 minutes. All right, so number 5, I told you that if you could do that one without filling in the table, you didn't need to, and you certainly should be able to answer whether this is a function or not without filling in the table. And we're talking about the diameter of a cookie. A diameter of a cookie, I can see that there's a 3 for the diameter, but you could certainly have a diameter that was 3.5 inches. There's nothing wrong with that. Distance can be values in between whole numbers, so that makes it really a continuous relation. I'm not going to go through and connect them all together, but it really is a continuous situation. And as we already decided, it's not a function, and can't really write an equation for that scenario right there. Number 6, y equals 4x was the equation given because every car has 4 tires. So like 1, 4, 2, 8, 3, 12, and so on. I'm just going to stop right there, and then you can plot your data and so on. But the main questions were whether this was a function or not, and it is a function. I mean, you can tell from the equation alone, y equals 4x, that it is a function. But the next question is, once you plotted your data, is this discrete or continuous? Is it discrete or continuous? Discrete. It's discrete. 3.5 motor vehicles, that does not make any sense, right? 3 cars does. 5 cars does. 7.842 cars does not. Therefore, this is a discrete situation. Number 7, we were given a table, and this is covering the cost for cars entering a toll booth based on how many passengers are in the car. Plot your data or just look at the table. This is a function. And then, once again, we're trying to determine discrete or continuous. Which one? Discrete or continuous? Discrete. Another discrete. So when you guys are doing 1 through 3 in the homework, I just know from experience, that's going to be the thing that's missed the most because you're not paying attention to whether you should connect your dots together or not. Now, fortunately, because there's so many parts in 1 through 3, you have 3 attempts to get it right. So hopefully, if you don't do it right the first time, you'll catch it the second or third time, if that happens to be the problem in 1 through 3. Okay? All right, so last idea for today. We have 3 scenarios here, and we're supposed to figure out which part of the scenario represents the independent variable and which part represents the dependent variable. Remember, for the dependent variable, it has to depend on something else. So we're going to do number 8 together. Number 8 says the math club is selling tickets to the Math Super Bowl. The more tickets they sell increases the amount of the money they can spend on beverages and food. Well, in that scenario, and you probably should add that to your notes, money earned depends on number of tickets sold. So that means that the money earned is the dependent variable. That's why I color-coded it there. And the number of tickets sold is the independent variable. The amount of money you earn depends on how many tickets you sell. So we're going to end today with you doing number 9 and 10 with your shoulder partner. Determine the dependent variable, determine the independent variable. I'll get back to you in 2 minutes. Go ahead. Number 9, the number of calories you burn increases as the number of minutes that you walk increases. So the number of calories burned is the dependent variable because that depends on the number of minutes that you walk. So the number of minutes walked is the independent variable. And number 10, as the amount of rain decreases, so does the water level of the river. So the water level is the dependent variable because that depends on the amount that is rain. So amount of rain is the independent variable. All right, we are finished. Do you know where the homework is? Go ahead and get started, please.